So welcome to my talk today. It's called Retiring the Singleton Pattern, Concrete Suggestions for What to Use Instead. My name is Pete Muldoon, and I am a software engineer in Bloomberg, based out of New York. So retiring the singleton pattern, I'll just go over a little the motivation for this talk. And it is a little controversial because I'm all for getting rid of the singleton pattern. And there is a certain pro-singleton crowd who believe that, as long as you use it judiciously and properly, that it's not a bad thing to do. I tend to go against that. The idea of the management of the class to a single type, I'm firmly in the camp of if you only need one, create one and pass it around and use it. I think we get too much into the sort of let's lock it down, sort of let's make sure that no one can possibly make a second instance of a class, and that causes all kinds of problems. But back to the motivation for this talk. So I've been doing software development for about 30 plus years, 21 years of that was as a consultant. And I've seen a lot of different systems, been in a lot of different spots where singletons have been used. I have to say, I have actually never in my career written a singleton, though I've had to use plenty of them when I've gone into legacy code. The Gang of Four, when they created the design patterns book, labeled it as a particular design pattern, gave it a lot of legitimacy. And it's very handy to use, but it has a lot of drawbacks. So anyhow, I first sort of got the idea from this talk by seeing some email that had come across my desk. We have a repo, sort of repository where we have pull requests, and it had changed this to use a singleton, changed communications to use a singleton. And I was quite taken aback, even though this was a legacy code base, that someone was taking code that was not a singleton and making it a singleton. So I walked over to the guy who'd made the change and I asked him, how come you're creating a singleton where none needs to exist? And his response was, it's going to be a lot more efficient instead of creating this socket each time. It's inside a singleton. I don't have to use it, create it, use it, and then get rid of it. So it's efficient. I tried to explain some of the reasons why a singleton is not a good idea, and it really didn't seem to have much traction. And I think because for want of a better word, the culture or the prevalence of other singletons in the code meant that this really would not do anything too bad if we already had, lots of them running around. So anyhow, shortly after that, and this was, like I say, patching up something in legacy code base. So after that, in my own team, one of my colleagues had the word singleton on their screen in their IDE while I was walking past. And I stopped and I took a look and I was like, why would you be writing a singleton in brand new code? And this wasn't some upper management layer singleton. This was something right down in the guts. And this was a brand new code base, modern C++. And the explanation given was this has to be plugged into a legacy calls are made into this new code when it's actually released. And we have to inject the information, and there's no other way to do it because we can't get the other code base to change what it's done. It's always called the API in this way. So again, it's like we've been backed into a corner. So I didn't really want to settle for that explanation. So I said, look, give me the problem. Let me take it and see if I can solve it without singletons. And this is kind of what started the basis of my talk. So as we go through here, there's quite a few slides. And for questions at the end, we have a Q&A panel. You can put questions on there and people can upvote or downvote. I will get to probably all the questions at the end. We'll have a few polls in between. But if you do have a question, please put a slide number on it. Just makes it really efficient to go to the slide and talk about it straight off the bat without having to hunt around and sort of, waste people's time. So anyhow, I decided to, like I said, take this problem on, not using a singleton where I have a legacy code base plugging into our new code. And I decided to take a look out there. Singletons have been around a long time. Lots of people dislike singletons. I'm sure there had to be plenty of solutions out there. Surprisingly enough, there wasn't. Roughly half of what you find when you go and Google singletons is how to do the pattern properly. And the other half is telling you it's such a terrible thing to do, you should never do it. But I did find a clean code talk, part of the Google Clean Code Talks, called Global State and Singletons, given by a guy, Mishku Hevery. And it's a really good talk. It talks about what global state and singletons represent, how it makes them opaque to testing, how they're prone to misuse, and how you have this idea of doing the same thing and getting different answers. So I'd advise anyone to go over there and look at that. But the thing that caught my eye was on Stack Overflow. Someone had wrote up the questions. I guess he hadn't been around singletons too often, but he had asked a question, what is so bad about singletons? And there was plenty of responses about why it was so bad. There was also, I think, one or two saying that it's not bad, it's just used badly. But the part of the conversation that really caught my eye is the guy replied, the worst part of this whole topic is that people who hate singletons rarely give concrete suggestions for what to use instead. I think that's the crux of the issue. You can't just say, don't use a singleton and give no answer of what you should do instead. And even in the Clean Code Talks by Mishko, he was asked at the end by one of the audience, I have a widget and it was on some front end, and all the errors I put in there so they pop up in this widget. It's needed everywhere. What would I use instead of a singleton? Because it's really easy to use a singleton here. And the response was kind of along the lines of just refactor your whole code base. And I don't think that is a really practical suggestion. So that's why my talk is talking about practical suggestions, concrete suggestions for what to use instead of having to refactor your code base. And I'm in a rewrite of a legacy system right now, which is, I don't know, 3.5, 4 years in. It's a long process. And certainly when you do that, you can factor out the singletons. But if I have a legacy code base and I want to make it, less problematic and more testable, what do I do? Well, let's get to it and look at the classic singleton pattern, and I won't spend too much time here. But as you can see, we have this static instance function, and this is the only way that you can get your hands on an actual instance of this class. There is no ability to create two of these classes sequentially even. I can't create one in one function, get rid of it, create it in the other. That's the point of the singleton class. There's one created and it lasts for the program lifetime. So we have the notable characteristics. There's a single global instance of a type. That's all you get. You get one, you have to deal with it. It's globally accessible, again, via that instance function. You cannot get it anywhere else but this instance function, but you can get it from anywhere. So you can reach in the middle of any function you're in as long as you have the header. You also have global state that's mutable but tied to program lifetime. That means anything that's inside the singleton, indeed any objects that it may create and has inside of it, have lifetime usage. In other words, when I create it and when I use it in one function and I go use it in another, or I call the same function again, I can get different results because the state is held over. The initialization is out of your control, right? So you have these private constructors here. This would be more of, I guess, classic C. These days in modern, they would be deleted. And you have no assignment operators. And the way it's called is down here is you just create the instance and call the function. You also usually have a static initialization function, which has to be called for this instance to be usable. And this ends up showing up in main usually. And if you have a lot of singletons that are interdependent, these inits have to be called in the proper order. And if they're not called in the proper order, the thing usually blows up. What are the drawbacks of a singleton? These are some of the points I listed. I said to my colleague, it acts as hidden dependencies and functions that use it. What that means is that I have no idea looking at a header file that the implementation is using singletons. They're hidden dependencies. And because of that, I have no control of them. Being of no control, I have no dependency injection, so it's not testable. As we said, the initialization is out of your control. It starts in the beginning, usually with an init function. Once that's done, you can't create or do anything with it after that. You have multiple runs yielding different results, which is kind of a code insanity. I do the exact same thing and I get different results. And then, you know, when these singleton is used once, it's used everywhere. So you get them in groups. You know, certain calls have to be done in particular order. In Michaud Heverty's talk I referred to, he talks about a credit card object. And when he ran it in his suite of tests, it ran properly. When he took the test and ran it on its own, it cored. What was wrong? Well, he hadn't initialized a credit card processor singleton, and it still cored because that needed some kind of flow control singleton, which needed a database singleton. And there was a whole list of initializations needed in a particular order. And again, state is tied to program lifetime, so function calls in a particular order are necessary. Given this long laundry list of why we shouldn't use a singleton, why do people use it? Why is it so prevalent? Well, if you're internally in some large legacy code base and you're down at the bottom of a function and you need to grab something, you need to grab, I don't know, a cache, write something to a cache or send it out on a broadcast, passing this extra parameter down a 20 deep call chain is somewhat daunting. And it won't be that just the linear stack down to where you have it needs this added. It's almost like a poisoning of the whole function chain. Anything that ever calls this has to be able to put this value in. And this can cause a massive explosion in the amount of change you have to do. Another reason is that you have an API that other legacy code bases are using. And when you change your code, your interface, it's going to break their code. And this code may be very old, or maybe in a group where they don't believe it's an imperative for them to change. So you get stuck with not being able to change the code base. And like I said, another reason is efficiency. People say, I only create one of them and reuse it. And I always say, well, then only create one and reuse it yourself. So what was the point of the singleton? Well, it wasn't supposed to be granting global access to a value, right? The idea was to control the instantiation of a type, where we wanted to lock down that in this whole program, there can only be one instance of this type. That was the main value of the singleton pattern as proposed. However, it's more frequently used for just easy access from, a random place to get your hands on something. So anyway, that is the reasons given for it. So I'm now going to have some questions and some polls, right? So the first poll I'm going to have is, we have a little piece of code here, and I would like everyone to participate. It's completely anonymous, but I have this extern int throttle limit. And this throttle limit, if I look in the CPP file, if you see below, is just set to 100. Maybe this is the amount of requests you can handle. So I'm going to give you all a poll. Is throttle limit a singleton? So you can vote yes or no. Is throttle limit a singleton? And if you've seen this talk before, you'll probably, you'll have the answer, but let's see how it goes. I'll give another few seconds. The results are still coming in. Not a trick question. Like I say, simple int, and we set it in the CPP file. All right, I'm going to end the polling and show everybody the results. So we had in the initial going, no was quite strong, but the yeses caught up with it. All right, so I'm going to, so it was roughly, I'll say that's a 50-50 split. So now I'm going to concentrate on the get thread limit function. So get thread limit function is something we have an interface that's going to return, I guess, the number of threads you can have in a thread pool, something like this. And as you see below, it's set during the first call. This is set to some sort of figure limit happens, set once on the first call into get thread limit. And then it returns the actual number, and that will not change for the lifetime of the program. So again, I'm going to ask my audience, is get thread limit returning a singleton? And if you can just pop your answers in there, it's interesting to watch them appear. Again, it's pretty simple. All right, get thread limit just returns some kind of pre-configured limit. So that int gets returned saying, here's what my thread limit is for the lifetime of the program. All right, I'm going to end the polling and share the results. And again, this one slightly favors the singleton. So we have a 59% versus 41%. All right, again, nice one. Let me just ask you one final question. And for that, I'm going to reveal a little more of the slide. So here is part of our IO stream file, I believe. So we have a namespace, the stud namespace, and I have a bunch of streams, the I stream for cin, the O stream for cout, O stream cr and clog. So these things are declared as part of the, like I said, the stud. So who thinks that cout, which we use all the time, all right, who thinks cout is a singleton? Right, something we use everywhere. We just reach out and grab it. We don't have to pass it around. It's nice and handy to get our hands on. Who here believes cout is a singleton? All right, I'm going to end the polling just about there. We seem to have gotten most of the results. Let me share the results with everybody. So again, this seemed to lean quite a bit more at what, about 2 to 1, 68% to 32%, so about 2/3 towards it being a singleton. All right, well, thanks for the participation. So I will contend that none of these are singletons, and let me explain my reason why. We see there that it's a type that can have only one instance. So this is part of the confusion, I think, with singletons, right? We have a singleton as a type. I cannot create more than one of these types. And anything that uses that singleton has to use that particular instance of a type. It's type control. It's a single instance of a type. So if we look at throttle limit, it's returning an int. And I don't think anyone would say an int is a single instance. You can only create one int for the lifetime of your program. I can create many ints, right? And any program or any function that's having throttle limit dropped into it, I could drop in something else. I could say, you know, I'm testing a class that normally has this throttle limit dropped in, but in my test, I'm going to put 0 as the throttle limit and see how it reacts, or I'm going to put, you know, max int in it and see how it reacts. All right, so it's not a singleton. It's just single valued. And it's the same thing with get thread limit. So get thread limit is just returning a simple int. Anything that is using that int to figure out its threads, I could put something else in, I could override it. All right. If we get into the idea of thinking that just a value that's declared like a variable is a singleton just because, you know, it's a value. In other words, I have an int x, and I set it equal to 4. Well, that's a singleton because it's an int, it equals 4. It really doesn't make sense, but I do know how people sort of feel it is. But again, singleton controls the types. So given that's the case, let me take you to what was a rough mock-up of my first attempt to get rid of the singleton. So I had this send data function. It took a data structure inside of it. It took that data, it transformed it, enriched it, enhanced it, mutated this data in all kinds of ways. And at the end, it called the singleton instance method and called the send. In the main, there was an init on the instance of the com singleton. So if I was to look at what's going on here diagrammatically, what I really have is a function send data that's taking the data as an input parameter, but it has essentially two outputs. It has a response coming back, which is easily interrogatable. It tells you, did it go well? Was there a problem? But it has a side effect of sending this request, this new data structure out, which I can't get my hands on. And even if response says everything went okay, I want to check if the request looks proper. All right. So again, how do we get our hands on the request? And with a singleton there, it's virtually impossible. It's really the only way you can do it is putting backdoors in. Not a good idea in production, or defined in public as private, which may practically work, but is undefined behavior. So let me give myself some requirements as opposed to just refactoring the whole code. I'm going to give myself some constraints. The new function must at least be source compatible. And what I mean by that is any users of the send data function, any libraries that call it, any other code that call it, should not have to change because of me taking the singleton out. So that's number one. I would like to express that there is actually some agency involved in sending stuff around. I'd like to put that somewhere in the header so people know, as opposed to having to comb through the implementation. And although it's 4 lines here, it could be 400 lines in some legacy code. It would not be unusual. I want to allow dependency injection for testing purposes. In fact, this is probably one of my biggest asks out of the thing. I want to be able to properly test this function and see that the request was formed correctly. So I took my first crack at this, and I'll say, okay, you know what? I'm going to add a dependency into the function. So you see I have a com singleton pointer being passed in. And at least now in the header, I'm going to see that there is a comms agency involved. And I'm going to give it the instance function to initialize that. So that means that anyone who calls send data with the single data parameter doesn't know. As long as they recompile, this thing just still works. But if I check my list here, do I have source compatibility? Yes. Do I express the involvement of the outside agency? Absolutely. But what about dependency injection for testing purposes? I still have no way to test this function. So it's marginally better, but it doesn't go anywhere near far enough. So what will I do? Well, I'm going to throw out the singleton class, but I'm going to replace it with something else. And obviously, I'm not going to name it singleton. So I've just decided here to call it a com wrapper. What I'm going to do is take anything that was in the static initialize call to the original singleton and drop that code into the constructor. Here, it's just a service ID that gets dropped in. Based on the service ID, I guess it'll base where it sends this. I take all the code that was in the send function of the singleton and I drop it into the send function of this wrapper. You'll notice I don't make it, hide the copying or make it that you can't make a copy. Anybody can create a com wrapper here, even without a service ID. It'll default to the one above, which I assume is where it's probably normally used. Any members that are needed, again, they just go into the private data section. So I have control over creating this. I can create this com wrapper from scratch anywhere I care to, and I can get rid of it. I have in here a TCP client, which is used underneath the covers for this. And the only reason I put that in there is because in there is a socket and I can't copy a socket. And that's going to cause me trouble down the line. And indeed caused me trouble when I did this first initial cut of trying to take the singleton out. Now, one thing I'm going to need is I also put in there this service struct with a static com wrapper in it. So what is this? This is going to give me something for a placeholder for people who want to call it with a single value. Again, I have to keep it API compatible. I can't just break everybody's code. And this is going to let me do it. But this, again, is not a singleton. I have a single instance called com underscore inside of this service wrapper. But no one's under any obligation to use it. Indeed, they can create their own com wrappers, and I would hope they would do it. So if I go back to my send data function, what happens is I'm going to make a 2-parameter version of it. So you have the original data, which people have been passing from time immemorial. And I now have a com wrapper com's been passed in, and that's going to pass in that statically initialized instance com underscore that was in my header file. Now what happens is I have, the ability to call this thing with just the data or with my own version of a com wrapper. However, have we dependency injection? We still don't have it, right? Because if I drop a com wrapper in, it's going to have to do the real thing. I can't drop a mock, and if I drop a derived class, I'm going to have slicing of the object. It's still going to call the com wrapper send. So all I'm going to do, right, is something simple. Just put a virtual function, give me runtime dispatch. And now when I go back here, any derived class from com wrapper, which is what my test will be, can be dropped in here. And now I have dependency injection, right? I can get my hands on the request and examine it. So let's take a look and see how we do that. So there's my com wrapper class, and I'm going to derive off a com tester. So I'm going to do the testing by hand here. And I'm going to say the com tester takes this request reference because I'm going to drop in my own request, and I want it filled in. And when send is called on this class, it's just going to copy whatever request was passed in by the function that calls it into the reference of what was passed in the constructor. And I'll return just a regular response that'll say, okay. So now my test data function, I create the data record and I fill it full of information. Here I just put an ID in, but I would fill the record with whatever information is normally in there. And I have my local request object, a rec. Now I'm going to create my derived com tester and give it the rec so it has a reference to it. And then I call the send data function, giving it this a client, right? The test function that's put in. What's going to happen down in the send data function is going to do all its data manipulation with my data record. And then it's going to call the a client.send. And that's just going to copy it into my local variable rec. So when I come out of the send data function, I can now check the sender ID, make sure it matches what was in my record, and I can check various parts of it. The whole request is open for introspection. All right, so I now have a previously opaque function that's testable, and no one had to recompile, no one had to deal with a new interface or change their code. So where I am, we use Google Test. So there I don't have to write my own test classes. All as I do is I create a mock client from my com wrapper. And I just said, look, I'm going to have a mock method that takes one argument, mock method 1. It's called send. Its function signature is it takes a const request reference and returns a response. All right. And my test will look pretty similar to before. I'll just create this mock client, except now I have an expectations. I can say you can expect this to be called on this particular a client object. It's going to have its send call. I don't care what it's called with, but it will be done once. And once you do that, I want you to take whatever was passed in as your argument and copy it into my local request. Again, the send data call is called. It does all that data manipulation. And then when I come out, I can assert that the request object has the field set properly so that I can validate everything that's in the request. So again, I have dependency injection. It's now testable. If you'd rather do this, so that was doing it in a, what people would call a classical way of doing things. These days, people like to use the stud function and do the type erasure without having virtuals littering. So, okay, we can do it that way. All as I do is I change my comms func to be a stud function that has the same signature, the const request reference, and returning a response. And now all I say is in my send data header, look, my comms func is going to take the exact same static instance of the com that I've created for people who don't want to create their own version. So again, it's not a singleton because there's no single type constraints on the com wrapper. So this is, I guess, a-okay, except for there is a possible problem here. And this is what I alluded to earlier. I actually did get this problem happening. So a copy has been introduced. When stud function does its type erasure, it copies in whatever the functor or function that it's going to be using. So over here, we have a comms func, and it's copying in exactly what service.com is. This has two problems. If service.com is a very large object, okay, then the stud function does have a small buffer optimization saying that if it's something small, just copy it in here. However, if it's larger than this particular buffer, it does a malloc, and now you're onto the heap, and that's really inefficient. The other thing is if you have something like I did, which was uncopyable, you're going to get a compile error saying you can't copy the TCP socket underneath here. So how am I going to, get my way around this? Well, it's pretty simple. All I got to do is use stud ref, and that will give anything that it uses a reference semantic, right? It returns essentially a reference wrapper with just a pointer or a reference to whatever we've given in its argument. So now we can do this. The only difference is we don't need any virtual on our com wrapper because we're using the parens operator. If, however, we have something where we have multiple operations on this, on the original singleton, this probably won't work. You'll have to go back to using virtual functions. All right. So testing this, again, testing straightforward. Okay, you can't mock the parens in Google Tests, so you just mock the send and dispatch it, forward it to from the parens to the send function. And again, I just create the same kind of thing, looks exactly the same, just call the send data with the parens operator. Now, if you happen to have, your class did have nothing in it that had no problem copying, you're just going to get a problem because Google Test does not allow you to copy mocks. So even if you hadn't in the beginning needed it, you'll need the stud ref down here because Google mock will stop you making copies. So as I said before, the stud function is something that copies the functionality into it. But once we use the stud ref, it's going to be small. So it's going to fit into that small buffer optimization. However, there is still a potential performance hit here because every time we call the send data request here, we create a new comms func object. And that can have some performance implications. And when I gave this talk previously, I had someone come up from the audience afterwards and say, hey, how could I do that without all this copying of the functor? Well, as usual, it just needs an extra layer of indirection. Okay, so what I used to call the com wrapper is relabeled the com wrapper impl. And now what I have is a com wrapper class that captures that com func in the beginning in its constructor. So this is only going to be called once. It's one copy. And once I'm in there, I can now call this operator and just forward it to the comms wrapper impl. And in fact, there's no reason why I couldn't change this to be a send. And again, my com wrapper static instance they're going to use for the injecting of information for people who don't want to change their API, we'll just call the call wrapper impl class. All right, so when we go back here, like I say, it's going to look pretty much the same. So I went to QuickBench and I put these things in. Unfortunately, when you use QuickBench, it all goes in like the same file. So I tried to do what's called no IPA, no interprocess analysis, meaning trying to stop a lot of the, the tricks that would be used if it was all in the one file. And the one on the far left is the function object where I created each time. The pink one right beside it is where I capture it and only copy it the one time, so it's a little more efficient. And then the base func and non-base func is just whether I made it a base or a non-virtual function, and the black is a no-op. Really, the base func ones are statistically equal. I also did this on O3 just to see what happens. And as it turned out, again, copying the functor all the time turned out to be a small bit of a performance hit. But again, I wouldn't take too much from these examples. Again, you can try it yourself. It's not that hard. And measure, and see how it works for your application. All right, so let's go back to my initial way. I've got my dependency injection. I can test this thing now, and things are pretty good. However, I also had someone come up and say to me, you know, if you are shipping a library, you wouldn't be allowed to change these function signatures, because that would cause the ABI to break, and someone would need to recompile as opposed to just take your new dynamic library. So true. So if I'm shipping a shared library, I would need my function signatures to be stable, because if you look at the send data in the header file above, adding that extra parameter in a default will definitely affect the name mangling. So your linker won't find it anymore. And that's a problem. So how do we get around that? It's a pretty straightforward solution, as are most of these solutions. A little bit of thought and you get there. So here, what I'm doing is I'm going to say, leave the original function as it was, well, as it was with the COM wrapper in it, except there's no default this time. So all of the implementation detail, all of the mutation of data happens in this 2-parameter send data function. I introduce a new function that has the old signature on it here. And all that is going to do is dispatch. That's going to say, for people who want to call the single parameter version, I'm going to put the static instance in and just forward it to the 2-parameter function. But the 2-parameter function is where the implementation is. It's got dependency injection, and I can test it just like before. Now, I actually did this, and I came across a problem because, like I say, there was sockets and stuff, not sockets, there was file descriptors. And I changed the singleton out for a COM wrapper. And then what happened is the program was pushed out to production, and I got a ticket back saying there was approximately double the amount of file descriptors open throughout the company. It was a very widely used piece of code. And it turned out that because I created this thing statically, it was created before main ran. And when main ran, it forked off a process, which became the main application process. But that meant that I had created a descriptor in the forked off process and left one in the original. So this was a small bit embarrassing. So what can I do to control the instantiation of this? Well, I've got to say, well, this has to happen. So there we have it, right? The potential problem was before the default instance was run, it was created before main ran, and that caused me problems. Other problems is you may have dependencies from one static, singleton across to another, or COM wrapper to another wrapper. These can go across translation units and cause problems. Some setup initialization may need to happen before your object is created. So we just borrow the trick out of the Singleton playbook and have lazy initialization, right? It's pretty well understood. All I'm going to say is inside of this is for the pre-C++ 11 crew. We can take the COM wrapper pointer, set it to null initially. And when someone calls get default coms, what happens is we will create the COM wrapper right here. Okay. Now, what is compiler do once? Well, it looks like a macro. It actually is a macro. So the problem with just putting a mutex there, so we're going to deal in multi-threaded the world now. So if I have just a mutex there, I really don't need the mutex for most of the lifetime. Just in the very first guy coming in wants to set it. Once it's set, really, I don't want to be hammering on a mutex by all these callers. So there's this thing called double check locking, where what would happen is you would look at the COM pointer first. And if it's null, you would then acquire the mutex. And once you acquire the mutex, you could try to reacquire the coms and check, is it still null? This was done kind of somewhat well. It was sort of tricky, but it was done different based on the compilers. So the compiler do once is just something that first time you're in, creates it the one time and it never does it again. In Bloomberg, it's a lot more hieroglyphical what that macro looks like. But anyhow, now what I have is once I come in here the first time I create it, so I control construction to the first time it's used, which will be after main. And again, this just means that I'm now going to have the ability to control it in modern C++, which is the becoming more and more the norm, you can just use the static initialization inside a function, like down here. What this means is that we're going to, it already has double check locking as part of the standard. They fixed it when they went to 11, so it'll only be called on the first run through. And again, it's not a singleton. I'm returning a type that you can create any number of. But this allows me to change my, my dispatch function. My send data function remains the same, but my dispatch function, instead of just using a static variable, now calls that get default comms function. That will initialize my first, on my first pass through it. Everyone else will get that same instance, and it'll get passed through to the dispatch function. So pretty cool. So let's look at what we've done so far. We've taken a function send data that took a data in and essentially had two outputs. One we could examine the response, and one we couldn't, the request. And we've split it out. We've done something where now we have a 2-parameter function which has all the mutation, and if it's old legacy code, all the nastiness, all the tricks, all the stuff you really don't want to even look at, you don't want to try and decode. And we've made it a 2-parameter function. Okay. Now, on the other hand, for the people that keep that ABI, we'll actually keep the ABI, but we keep the API as well. All the people that are using your send data function are oblivious. It would be nice if you could convince them to create their own COM wrapper and make sure, you know, they hang on to it and pass it in when it's needed. A lot of time that's not going to happen because you're generally in a group with less power or less ability to push the group using your stuff. But we have now separated it where we have just a dispatch function. And really there's nothing in the dispatch function that needs testing. I mean, if you want to test against default, you can test it elsewhere and just make sure that the default is set up properly somehow. But all the implementation, we've separated it out. And I think this is really a very big thing we've managed to accomplish here. From a function that just was not testable to being completely testable. Okay. So I've gone and I've taken my send data function. Like I say, I've transformed it like we talked about. There's a 2-parameter. I can see the dependency in the header file. I can control it in my test files. And I've kept the original signature for my legacy users. However, I can have this kind of problem here where although I've gone into the legacy code base and rearranged the send data function to do what I wanted to do, the send x data function also uses it. And maybe there's, I don't know, it's 100 places, it's 200 places inside the legacy code base. And you've gone in to make a modest change and do a small piece of good by making this send data function testable. But it really does be a heavy lift to try and go in there and change it everywhere. And also risk the problem of creating a problem everywhere. So, and I had a colleague who had this problem. He had, I think, 200 and something instances where this thing was used. And he was like, I can't just use it there. And one of the suggestions is that, why don't I have the get default comms just return my com singleton instance? I don't think we've gotten very far there. I mean, the idea there is that when I do this everywhere and I eventually have every place changed over, I can change the singleton out. True enough, but I don't think people will actually come back. It's a lot easier to get people to change things while they're in there than to come back and change them a while later. So let me go look at this phased introduction that I'm going to introduce, which is a way for you to take a bite-sized chunk of what's going on. So we have this class singleton. It's been set up to handle the multi-threaded. We have the private constructors. And down here, and in many instances of the code, we're going to have this kind of call the instance send on it. So what if I was to change this in the following manner? So I take my con singleton and I get rid of the private instance member and I have it return the com wrapper. Right, let me just show you that again. So look at the instance function. We were returning a com singleton instance, but now I'm just going to return the wrapper from my default comms. And anywhere, as you see in the bottom, where people are calling the com singleton instance send function, it will just compile and it will do the right thing. What that means now is in my send, if my send x data function is called first, it's going to go in, call the instance send method, which is going to call the get default comms, which will create the static instance and return it back. If the send data gets called first, it's going to explicitly call the get default comms, and it's going to return it back. Right. So what we have here is, although send x data has no dependency injection, what it is actually going to do is allow us to put our new wrapper in instead of the singleton. We can come back sometime later, that may be never, but we can come back sometime later and update the x data function, the send y data function, and so on and so forth. Right. As long as the singleton pointer itself is not named. And like I say, I've been in the industry a long time, and I don't think I've ever seen inside a function we take this singleton instance pointer, name it, and use it further down the function. Because the instance method is so handy, it's just used at the point it's needed. So usually this will work. Now let's get back to the idea of, we have a traditional singleton approach. And if you think singletons are one per function or one per class or something, you are sadly mistaken. If someone had their hands on the singleton approach, it's going to be all over the place. And we can have interdependency of these singletons. And this is what Michaud Heverty was talking about in his clean code talk. So I have a com singleton, and unbeknownst to me, it needs a cache for some reason. And the cache, unbeknownst to the com, needs a DB. So I have no idea that there's these set of singletons going on. And what's furthermore, these need to be initialized. So in the main function, I come along and I say, okay, I'm going to initialize the com, I'm going to initialize the cache, I'm going to initialize the DB. They may or may not need parameters for this to happen. They may reach out to a configuration singleton for all I know. But oops, look, I made an error. Right, I initialized the com singleton, but I really should have done the DB first, because the cache needs the DB to initialize, and the com needs the cache to be initialized. And lots of times, if you don't do this in the right order, and I'll show you here, the right order should have been the D in least dependency going up, you don't get it properly. Right, the thing will either blow up or your com stops working. You get sort of, I don't know, I guess a form of undefined behavior happening. So what can I do to sort of prevent this kind of, needing a secret recipe? I've got to go ask team members, hey, I'm using one of these com singletons. Oh, yeah. You forgot about a DB init, I bet, and a cache init. And so it's kind of like a voodoo, some kind of magic you got to get your hands on. So the DB wrapper, when I replace the DB singleton, it has no dependencies. We've already talked about that, but let's talk about the cache wrapper, which needs the database wrapper for it to work properly. So let's make that explicit. Instead of some kind of init call in the constructor, I drop in the database wrapper reference, and I hold that reference inside the class. So inside my save, or presumably I'm going to do something with the cache wrapper, I just use the database wrapper. I'm just going to call whatever functionality I need on it. In the com wrapper, I need a cache wrapper. Make it explicit. Here's my cache wrapper. You drop it in and do the same thing. We have a cache wrapper reference held in the class, which has gotten construction. You can't create these classes without the proper dependencies in them. What that's going to mean now is, in my get default comms, I'm going to say, get me a default cache, because if I try and create the com wrapper on its own, I'm going to get a problem, right? I'm going to get a compile error. Once the com asks the cache to do its stuff, the cache says, okay, I'm going to create a static cache, but you know what? I'm going to get a default DB because I have to. I can't do it without it. So I'm going to call up to the default DB. That's going to create a database wrapper. It has no dependencies. And then we're going to return down the chain. The database gets corrected and returns, or gets constructed and returns. The default cache is going to have a cache wrapper constructed. Now it can return the cache. So the comms has the cache, and now it can return itself. So doing it this way, we don't have to worry about any special init calls in main. We don't have to worry about the order. It's built into the language. This is why we have constructors, right? And if I want to test this thing, again, my test doesn't look that much different. All as I'm going to do is say, look, I have a database wrapper. It's the same as we've been talking about before. When I do my mock client, well, then you got to pass me a mock DB client in, and I'm going to drop that into the cache wrapper, right? You can see that here. And then when I go to create my mock from my COM wrapper, my mock COM client, all I'm going to do, again, I'm going to drop in the mock I created. That's going to drop it into the COM wrapper. And I'm going to say each of these, you have a method in the cache, and the DB it's a save, and in the COM it's a send. So now in my test, all as I do is I create my 3 clients. I have to create them in this way. I can't create the COM client first. I create the DB client. I'm forced to do it properly. I then have my data record, which I put the data into. And then I say, here's my expectations. Expect these particular calls. Here, I'm just going to do it once. And each of these arguments can be saved into a separate local request object, which I now at the bottom can do assertions on. Check that the COM request has this in it. I could also check that the cache request looks like this and that the COM request looks like this. All right, as long as I return the proper data in my response. So that's one way. So if we look at that as if we were looking at a dependency graph, that's lengthways, right? This depends on this, depends on this. We'll have a kind of a depth-wise as well. So I'm inside my function, and instead of it just calling a single function or a single singleton function, it calls functions in multiple singletons. That's kind of like multiple singletons in the same legacy function, and it's quite prevalent inside of legacy functions. So how do I do that? I've got a bunch of dependencies I need to pass in now. I don't want to do it with a lot of boilerplate or something that's really strange to look at. I want to have it kind of be simple looking. How will I do that? Well, let me take my first crack at it. Again, I'm going to say, here's the kind of dependency graph here inside of the send data. I'm going to have COM, database, cache, and MQ to do with the data. So I can do it in brute force, right? If we look down here, I now have a send data function that takes my original data function and a bunch of wrappers, right? And although there is an argument to be made while I'm showing all the dependencies, there's also an argument to be made that you're cluttering up the function header with a bunch of, a bunch of stuff that's making it hard to figure out what you pass in here. Fair enough. I keep the original signature function and I just call a bunch of get defaults. Again, this is brute force. I don't like to see it. And this is the kind of road you go down where you end up seeing, 40 parameter functions in legacy code. So what would I do? Well, I think a natural thing to reach for would be some kind of struct. I'll bucket it up. There are a bunch of things that are somewhat related, but not codependent. And I'll put them into my service struct. And then I'll have, instead of a bunch of get default classes, I'll just have a get default service. So I'm kind of wrapping them all and saying, I've got this one place I can put this information. So looking at my send data function, I have the single parameter version right here. And what it's doing is just doing a get default services and dispatching it over to the send data function with all the implementation detail in it. And throughout there, it'll call my services.db.save. I just go through the various pieces that it needs. So great. Great, apart from the fact I have no dependency injection. When you create the services, it's a fully fledged service and it has fully fledged versions of all its members. There's no way of overriding what's in there or saying, hey, I want you to use a mock version. So what can I do? Sounds like a job for templates to me, right? I can take my send data and say, you know what, I have a template type named service. Here's my recipe. And do all the stuff that was normally done there. But at the bottom, I'm going to have a services. And as long as whatever I pass in has a member that's a database called DB underscore and a save method on it that takes this request, I'm golden. Everything works. However, this has a problem because this is in a CPP file. And there is, for templates, you're not going to be able, way over in your test file, be able to say, look, create me a send data with my mock service in it. because your compiler is not going to see it. It's not going to have a recipe for it. So there is a way of doing it. A little unorthodox in that you must at the top include your mock service. So it has your testing service in it. And then at the bottom, you have to say, look, I'm going to tell it. Normally the compiler will implicitly figure out whether it needs to create various variations of the send data function based on the types. But I can explicitly tell the compiler with explicit instantiation down here that the send data function needs to be done with a mock service. Believe me, I'm going to need it sometime later, so please create it. Like I say, it's a little unorthodox. If you have production code and use static linking, it won't bring it in, it'll get dropped. But again, it's a little unorthodox having your mock stuff show up in your production CPPs, though you may get it through on the pretense that it's legacy code. But you've probably gone down the wrong road, right? You've dug yourself a hole and you're trying to dig yourself out. Well, the better way is to back up and just hop out of that particular hole. So it's much easier accomplished by just saying, my service is just a bunch of references. And references won't have object slicing. I'll have to create a constructor on it like above if I'm pre-C++ 11. If I'm not, I can just use the aggregate initialization. And that just means that my get default services now looks something like this. So for anybody who's going to use the dispatch function, the single parameter version, we'll just have a get default services that says, let me create all the various bits and pieces I need, and then I'll put them into the service and return it. So we now have a send data function. The get default services gets pushed in. Whatever's in that services will have its DB member and the save called. I'm now back to runtime dispatch if I have virtual functions. If I have type erasure, I would just call the parens and it would still work. The clients are just going to look a bunch like the original client. So I have a couple of mocks going on here, each derived, and I'm just going to say the mock method, just take whatever you're given, and here's the function signature. In my actual test, I can create these clients in any order. Essentially, there is no internal dependencies here, and then I'll create my own service object by dropping these in. I'll have a bunch of different requests. I'll set my expectations, meaning that each one of you is going to take whatever you're giving it and return it into my local variable. And then when I call it with my data rec, I put my data record in there and I call the send data. I can now interrogate every one of the services that was called. I can talk to their request object and see, hey, does it look like what it's supposed to be? Here, I just checked that the ID is the same everywhere. So that's a length and a breadth. Pretty cool. So I can pretty much replace any set of dependencies inside of a function on Singleton with just the equivalent wrappers, and have the language manage the dependencies instead of me having to do it. So let me take you back to the send data function. So here I've done my dispatch functions, which we know under the hood are just going to call it default and send it on to the 2 parameter versions here. And I went back, being the good guy that I am, I went back and I also did the same thing for the sendX data function. Okay. But what would happen if these are not free floating functions? They actually are in some kind of send processor like we have here. No disrespect to the functional programming crowd, but I prefer my stuff in classes. Okay, so now I have a little more leeway. We could factor, the service out by saying, let's just capture it in the constructor. So you see here, my first constructor has an auto client service being passed in. So again, here's my dependency injection. And that's captured in a reference, a member reference, the auto client reference services underscore. And these would be in the CPP. This is if you have problems or worried about ABI problems down the road. But now let's look at my refactored functions, because now I don't need to pass the auto client services in. right? I now have it as a data member. So I can get rid of the functions. And what look like now the dispatch functions will actually be the full implementation, because all as I will do in my send data function is, instead of saying get me the services, I will just use the member data, which has been set up in the constructor. So I think pretty neat, all right? So now, what have I got here? Yeah, this is what I was just talking about before. All right, I actually went the wrong way, sorry. So now in my stateful dependency testing, all I have to do is I set up my clients just like I did before, drop them in, set up my expectations. And then down here, the only difference, this is pretty much the same as we'd seen before. The only difference you're going to have is that the constructor is going to get the services dropped in as opposed to every time I call. And here, as you see, I call the send data function. I do a bunch of checking that, assert various things are correct. Then I can check the send x data function and check that it has done stuff correct. All right. Now, this is just a fit on the slide. In reality, you would have something to do a test on the send data and a different function do the send x data. But for keeping the slides brief, this is how I've chosen to do it. But it's eliminating the need to pass it into the functions. You pass it in the beginning and it's done. So it's become a lot more tidier because we have stateful dependencies. So doing this now, I can say, look, I have some kind of biz singleton, right? Someone has created some kind of business singleton. You know what? Inside of it, it called 3 singletons, a cache, a TC val, a tran. I had to make sure in my main, this is the way it was happening, that was done in the proper dependency order. Turned out TC val depend on store, but cache depended on DB as did store. So I can have any kind of graph here. But now, we have looked at. I can take the biz, create a wrapper, create wrappers for all of these, and have the dependency happen as natural programming features. I can't do it wrong. It has to be done right. Okay. So pretty cool. Now, I gave this talk previously, and the great thing about giving this talk is people will come to me and say, oh, look, here's what's going on, and I get to see a menagerie of uses of the singleton, some quite surprising. But some people would ask me, look, even though it's a singleton, it's configurable, and how would you inject configuration? Because what you have doesn't allow configuration to be injected. To which I say, not true. And let me show you. So this is some new material on the talk. So let's say I have some sort of configuration structure or class. It takes a file name, it goes in there to that file name, processes it, doesn't matter whether it's JSON or your own format. But at the end of the day, what I can do is say, you know what, here's a key, give me back my type. And here I just call it param, it might be a variant or it could be your own type, whatever it is. It's just a way of getting some piece of information out of the config that is used. So going back to what I've used before, I can say, you know what, let me create a default config. To my mind, configuration is given at the beginning of a program and never changes. So it's a long-lived object, all right? And that is perfectly fits in with the theme, because that's all that singletons are, is long-lived objects, but they do actually do that type restriction on you. We've removed that, but they are long-lived objects. So let's say we have a default config. And what I'm going to do here is say, look, when you create my static instance, check if the file name is empty. And I have a ternary expression here says that if it's empty, I want to throw. And if it's not, you just use the file name. And this is just an extra safety measure. Look, inside of the config object yourself, you could do this check and throw. But here what happens is if anyone tries to use this default config before it's set, we throw. We say we can't. Hopefully you have a try catch block. If not, your program's going to exit. So given I'm able to inject configuration, how does that affect my default comms? Well, all as I say now is, look, when you create the default comms, get me a default config, right? Because now the configuration is a dependency of your comms being set up. Fits right into the pattern, right? So what do I do now? But if someone calls that get default comm without me setting it up in my main, right? I don't have to do it in any particular order just before. we call the get default comms, it will throw. And this would normally be wrapped in a try-catch block, but for slideware, I don't have it there. Here, a program would exit if you didn't give a config file that was valid. Okay, so we have configuration now, seamlessly injected in. So what about injecting lifetimes? Because I had talked about the fact that at construction, if you have just these static objects that are created before main, and if there is dependencies going across from one singleton to another, it's a problem, and that's why we did lazy initialization. But there is, another problem where you have the destruction happening unordered, and you need ordered destruction of your objects. Now, if you've been replacing singleton, and my first answer to this when I first gave this talk was, if you have a singleton, you never had defined order of destruction anyway. So why are you asking me in my wrappers to give it to you? But it turns out people were taking this and using it anyhow. This kind of techniques of using without singletons in just places that weren't naturally singletons, I guess you would call it. And they wanted to have control of the lifetime and when it destroyed, not just that everything just goes in a big explosion at the end. So I said, okay, let me do this, because let's take a look at the code example that I have on the screen. If I create the default config here, and then I set my service running, and then sometime later the service is told to quit, I have here at the end of my main, the unordered destruction of my comms object that I created here statically. So I control the initialization of it, but I'm not controlling when it goes away. And this is potentially a problem for people. And I understand you need to do cleanup in a particular way. So again, how am I going to take care of this, inject this lifetime? Again, it's just an extension of what I've been talking about, right? So what I'm going to do now is say we have a default comms function, same way we had a default config function. And now people are going to pass me in a pointer to this particular object, right? And once I'm in here, we'll use that same trick I did the last time where I say, look, if you go to create this comms, make sure, if we're going to do it, that we have a valid pointer. All right, you can do whatever checks you want here, but we can check. And if it's not set, we're going to throw an error saying it was unset. All right, so we don't have this idea that someone doesn't set it and they just don't realize it. All right, we give a particular error, you didn't set this. Inside my main now, I'm going to say, look, I'm going to create my comms object. So here I am controlling the instantiation of my object. So I create the comms class here. And I, give it a default config. Again, if I hadn't set some config, it would be a problem. And then down here, I'm going to call my default comms to initialize it. Now, yes, I have to initialize the comms, but I'm told if I don't. But you asked to have control of the lifetime, so you have to take responsibility. All right. But now what happens is the default comms, the comms object here gets used throughout the life of the program. The service returns, and here at this closing brace, which is not at the end of main, I can get the destruction happens. If I had created, I don't know, a bunch of these, I created a comms and then I created a DB and a cache wrapper, put them into the default. At the end, they would get destroyed in the order they were created, right? To follow the normal rules of the language as we understand them. And again, if you say, but now I got to manage the lifetimes, that's a real hassle. You asked to manage the lifetimes. You don't want to manage the lifetimes, go back to what I had previous, right? But this way here, we now have the ability to say, I'm defining the construction, the destruction of my object, but my APIs all throughout my big legacy code base have been unaffected, right? And that can be a big thing. So let's have a quick review of what we talked about, because we got through quite a lot of subjects. So we talked about replacing singletons with, I call them a wrapper class, you can call them whatever you want. But we did it while keeping the API source compatible. Absolutely crucial in the legacy code base, because you can't get all the users and even internally all your own functions. It could be like a million lines of code root through them all and try and change them and hope you didn't break something else. So we keep the users of your function, the users that call it, source compatible. They don't have to make any change. And we also went to the extent of keeping it ABI compatible. All right, so we went and said, okay, look, we can do it where we don't even change the function signature by creating, 2 signatures. Avoid copies for classes with deleted or private copy constructor. So any members that are inside of there, which are not copyable, okay, we found a way to do that as well. That was just using the stud ref, right? It wasn't anything particular I did. Delayed initialization of resources. Again, a real problem I ran into, as was avoiding copies. How do we delay the initialization to when we want it to happen? And we showed that by making it lazy initialization. The phased introduction for replacing the singletons. All right, this is where we have the same singleton used in multiple functions for different uses. Here's a phased way of doing it, meaning you can do a small change over here and not have to change a whole code base. And pretty neat, and I think one of the big things to take away. Initialization order of interdependent singletons. The singletons will always, behind the scenes, reach out to other singletons. It's basically a guarantee. And you'll see in legacy code these long list of particular initializations that go on in main to make sure that it's done and done in the correct order. We talked about grouping the dependencies together so you don't poison the function signature with like lots and lots of these dependencies being passed in. And then we talked about stateful grouping, where instead of having, doubling the amount of functions and having to call it each time with that dependencies, you can just put it in the constructor and then it's all hidden from the user, which is really a nice way to go. And then we talked about these are new items where we injected a configuration in. We did that at the beginning. We made sure you can't run this thing without configuration. And then if you want control of the lifetimes, we talked about that. And we did all of this. We did all of this thing. And the main point of it was really, I don't know if it's even getting rid of singletons, but just getting rid of the biggest evil of singletons, right? Which is we injected dependency and testability. We are now able to test these functions. Previously untestable, now testable. And as I've said in previous talks, this allows me to sleep better at night, not because of my conscience and my morals, because I'm able to test the class. I don't get woke up at 4 a.m. in the morning. I'm in New York because the London market is open and we have a problem. All right, so here is my contact information. Anyone who's on YouTube, you won't be able to ask me questions live, but here is my contact. Feel free, I'm always happy and interested. It's really quite cool to see all the different uses of the singleton pattern or, variations of it, and how I can, try and solve it. And in fact, I know when I gave this talk at CPPCon, people came to me afterwards and actually went on to Godbolt and helped them solve their singleton problem. So I'm now going to open it up for questions. You have a question and answer board to the right. If anyone has questions, I'm ready for them. No questions so far. I see we have some chat that was going on. Which tool did I use for performance evaluation? Like I say, to do quick tests, I use QuickBench. But to do real tests, I would do it with a proper profiler in your application, right? Or have some performance metrics and see how it's affected. It depends. If you're in a low latency system, it'll probably be crucial. If your latency is not that big a deal, then it may not be. I always think that, before you bring in the complication of an extra layer of indirection, that you should try and use the simpler solution and realize there is one there you can go to, but you don't need to go to it yet. Again, measure, measure, measure. All right, well, if there are no more questions, I'll call it there. Thank you for attending the talk. I hope it was useful. And again, I will be in Remo. I'll post on the chat the table I'm sitting at. Feel free to come up to me. Oh, someone came in with a late question. Would you prefer the inheritance or stud function approach? I tend to prefer stud function for most things, but in this instance, I do prefer the inheritance approach, just because it allows me to name the functions, right, as opposed to just parens. And a lot of times I find that singletons have more than one function in it, right? There might be, for instance, in that singleton, there was, I think, an async send and a sync send. There was multiple functions you could call in it. I collapse it down for the talk, but in the real world, it gets messy. And because of that, I needed two different types. So I could have had two different functors and stuff like this, but it's really just easier to go the simpler route. And again, it didn't affect my performance in a way that was noticeable. When I ran the complete system, performance metrics didn't blink an eye. So I would lean towards inheritance if I had to take a pick. But some people, and there are people in my group that positively come out in a rash if I use inheritance. And even though I explained the type erasure is just a kind of way of doing a limited form of runtime dispatch, it still has an indirection. It really doesn't make much odds with them. So if that's it, like I say, I'll be around for probably the next 20 minutes or so in Remo. If you want to come up, I'll go to a table on my own if I can find one, and you can find me there. Other than that, go forth and do good. Remove those singletons, get rid of them. And when someone says it's not possible, please direct them to this talk. That's it.